Have you ever looked up at the sun and wondered how we can turn all that brilliant light into electricity? It seems like magic, but it's actually amazing science. Today, we're going to break down exactly how solar panels work, step by step, in a way that's super easy to understand. So let's start with the basics. A solar panel, also known as a photovoltaic or PV panel, is made up of many smaller units called solar cells. Think of it like a giant chocolate bar, where the panel is the whole bar and the solar cells are the individual squares. Most of these cells are made from silicon, which is a semiconductor. You can find silicon everywhere. It's the second most abundant element in the Earth's crust, right after oxygen. Now, here's where it gets interesting. To make a solar cell work, manufacturers take pure silicon and add other elements to it in a process called doping. They create two different layers of silicon. One layer is doped with phosphorus, which adds extra electrons, creating what we call the N-type or negative layer. The other layer is doped with boron, which creates holes or a shortage of electrons. This is the P-type or positive layer. When you put these two layers together, something cool happens at the junction where they meet. The extra electrons from the N-type layer jump over to fill the holes in the P-type layer. This movement creates an electric field right in the middle of the cell. You can think of this electric field as a one-way street or a slide. It sets up a permanent barrier that keeps the electrons from just flowing back. Okay, so we have our solar cell with its built-in electric field. Now what happens when sunlight hits it? Sunlight is made of tiny packets of energy called photons. When these photons strike the solar panel, they knock electrons loose from the silicon atoms in both the N-type and P-type layers. Remember that electric field we just talked about? It acts like a powerful force, pushing these newly freed electrons toward the N-type layer and the holes toward the P-type layer. This separation of charges is the key to creating an electric current. To actually use this electricity, metal conductive plates are placed on the top and bottom of the solar cell. These plates collect the separated electrons in holes. When we connect these plates with a wire, we create a circuit. The electrons, eager to get back to the holes they left behind, flow through this external circuit, creating a direct current, or DC electricity, and voila! That flow of electrons is the electricity that can power our devices. But wait, most homes and appliances run on alternating current or AC electricity, not DC. So how do we make that switch? This is where another crucial component comes in, the inverter. The DC electricity generated by the solar panels flows into an inverter. The inverter's job is to convert that DC electricity into AC electricity, making it usable for everything in your home, from your lights and TV to your washing machine. Once the electricity is converted to AC, it flows into your home's electrical panel, also known as a breaker box. From there, it's distributed throughout your house, powering your life with clean, renewable energy from the sun. And what happens if your panels produce more electricity than you're using? That excess energy doesn't go to waste. In many places, it can be sent back to the main power grid. Your utility meter will actually spin backward, and you can get credits on your electricity bill. This is called net metering. At night, or on very cloudy days when your panels aren't producing much power, you simply draw electricity from the grid as you normally would. So to recap, sunlight hits the solar panel, knocking electrons loose. An electric field inside the solar cells separates these electrons, creating a current. This DC electricity flows to an inverter, which converts it to usable AC electricity for your home. Any extra power can be sent back to the grid. It's a truly elegant process, turning sunlight directly into power with no moving parts and no emissions. From a simple silicon cell to a fully powered home, solar energy is a powerful tool in our transition to a cleaner, more sustainable future. Thanks so much for watching. If you found this explanation helpful, please give this video a thumbs up and subscribe for more content about science and technology. See you in the next one.